Okay, so now we're going to have a look at a magnetics example. So here we're told a factory worker winds 300 turns of wire around a 25 centimeter long tube. What current must flow through the wire in order to generate a field of 0.01 Teslas inside the tube? Okay, so we're going to draw a little picture of this. So we have some tube like so. It is 25 centimeters in length. Then it has some wire. And the wire sort of wraps around it like this a whole heap of times. And there's 300 turns. So the number of turns is 300. So we're asked what current must flow through the wire in order to generate a field inside the tube of 0.01 Teslas. So the field, which I'm calling F, has to be 0.01 T. Okay, so we have a field strength formula for this. We know that B, the strength of the field, is going to be equal to a constant times the number of turns times the current divided by, this should be I times the current divided by the length. Now this constant that we're using here is a constant common in electronics and magnetics. This is mu naught, which is 4 pi times 10 to the minus 7. So this is the value of this constant. Now we know most of these values. We know most of the values in this formula. We know that B has to be equal to 0.01. We know N is equal to 300. We know L is equal to 25 centimeters, which in meters will be 0.25 meters. The only thing we don't know is I, and that's the current, right? So that's what we need to find. So we're going to rearrange this for I. So multiply both sides by L, divide both sides by mu and N. We get I is equal to B times L over mu times N. If we plug everything in, the field strength is 0.01. The length is 0.25. This gets divided by mu, which is 4 pi times 10 to the minus 7, multiplied by the number of turns, which is 300. So if we plug this all into our calculator, we're going to get 0.01 times 0.25 divided by 4 times pi times 10 to the power of minus 7 multiplied by 300. And this gives me 6.6314 dot 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 dot. So therefore the current through the wire has to be about 6.64 or 6.63 to two decimal places amps. And so this is the answer.